So if you're looking at this and you want to figure out what he sells, you've been given two pieces. You've been given what his commission is, his commission amount, and his commission rate. All right? And so in order to calculate this, you're actually going to have to back into it. You're going to have to divide. If I take how much he sells, which I do not know, so I'm going to put a variable, and I multiply it by his commission rate, which I do know, and I'm going to put that in terms of decimals, that will equal his commission amount, which I also know. So for this one, you should have taken 7,000 and divided by 0.08. You would have gotten 87,500. 87,500. All right, let's look at the next one. A real estate agent gets 6% commission on lots he sells. He gets 3% on lots that he sells that someone else lists. So if he lists the lot, he's the one that they came to sell it, and he's the one that sells it to someone else, he gets 6%. If he sells it, but someone else had the listing, he only gets 3%. One week he sold a $90,000 lot listed with another company and a $65,500 lot that he listed. Find his commission. All right. So for this first one, the 90,000, what is his percentage that he's going to earn on that? It was listed with somebody else. So which percent am I going to multiply that by? The 3. So I'm going to say times 0.03. He also sold 65,500 that he had listed. So what's his percent on this one? 6. And if I add those two up, I will get his commission. And so that's how you should have set it up. 90,000 times 3% plus 65,000 times the 6%. And when you did that, you should have gotten $6,630. Motion. A jet leaves O'Hare Airport in Chicago at 7 a.m. and flies south towards Atlanta, 606 air miles away at an average speed of 420 miles an hour. At the same time, a jet leaves Atlanta and flies towards Chicago at an average rate of 500 miles an hour. Because of an error in calculations, the jets are flying at the same altitude and on the same route towards each other. This is a problem. How much time do the air traffic controllers have to change the direction or altitude of the jets before they collide? This is what's called a uniform motion problem. Uniform motion. All right? Distance will always equal your rate times your time. If you drive 60 miles an hour for 2 hours, you will drive 120 miles because you take your rate, you multiply by your time, and you get your distance, right? If you travel 120 miles for 2 hours to figure out your rate, you would divide by your time. So these will all depend on what you've been given and what you're trying to find as to whether or not you multiply, divide, and all that good stuff. For uniform motion, though, very often you will have two objects traveling, like in this particular case. You have one plane leaving Chicago, traveling towards Atlanta. You have another one leaving Atlanta, traveling towards Chicago. It's vitally important that they figure out when those two are going to meet if they're flying at the same altitude and on the same path. Okay? And so there's a certain amount of time, depending on how fast each one is traveling, as to how long they have before they meet in the air, which is not exactly what you want airplanes to do. Okay? And so uniform motion is going to have typically two things traveling. Sometimes you'll have leave this place, go, and come back, but it'll be two different travels that you're talking about, and you're comparing them. And depending on what you've been given and how you're comparing them is depending on how you're going to solve it. Okay, so we're going to look at some basic ones and how they're set up. Look at this first chart they give you at the top of page 129. They're just establishing some things here. No matter what you have in these places, you will always multiply your rate and time to get your distance. And so we are going to start setting up some charts here to do this. If you're traveling at 50 miles an hour for 3 hours, you would say 50 times 3, that's 150. If you're traveling for 50 miles an hour for a certain time that you do not know, you're going to put a T there. Be careful when you use a T because it can look like a plus sign, right? But T usually represents time, so then your distance would be 50 times T. Let's say you don't know your rate. Well, you would put a variable there. Typically, we use an R for 5 hours. Then your distance would be 5 times whatever that R is. Even if you have something like plus or minus here, which they didn't give us one, but we will do, or divided by or multiplied by, you would still multiply your rate and time to get your distance. Your rate and time to get your distance, okay? And so over and over and over, you're going to see this. And we are actually going to set up charts. We're going to have the first, whatever it is, airplane, person, whatever's traveling. The second, whatever is traveling. We are going to fill in from the word problem what we know or what relationship they have told us. And then we are going to decide what to do with the distances. Okay? So solving uniform motion, and these instructions are actually in your book on page 130. Read the problem. These will always be your instructions when you're solving a word problem. You have to read it. That's kind of important. All right? Read it carefully. All right? Make sure that when you're reading it, you're taking note of important things that they are telling you and important questions that they are asking you. You have to identify the main unknown in the problem. Let the variable stand for that. Sometimes drawing a diagram will help. We will be using tables as well. Plan a strategy. This is what we're going to do to plan our strategy is our table. Fill it in using your distance equals rate times time. Solve the equation. So once you set up your table will lead you to an equation, and then you will just use algebra to solve it. Get all your variables on one side, your numbers on the other, multiply or divide to get whatever your variable was. Check your answer. I've said this before. I will not give you things that don't make sense. If you're solving for time and you get a negative number, you did something wrong. We don't time travel in our word problems, right? And so time should always be positive. And if we didn't get positive, maybe we need to check and see how we set it up. All right, check your logic here. If someone is walking and you get like 50 miles an hour, maybe we need to check our problem because that's pretty fast, right? So that is like, speedy for someone walking. But on the other hand, if we're doing an airplane and it's 2 miles an hour, we're not off the ground. And so maybe we need to check our airplane speed. Unless we're taxiing down the runway, if we're in the air, we should probably be going faster than 2 miles an hour. So make sure your answer is logical, okay? Make sure your answer is logical, or else you probably did something wrong. And it's just a really quick, hey, I probably did something wrong, okay? Not that you can't get a logical answer and it be wrong, you can, but especially if it's glaring that something's wrong with it. Go back and see what you did. All right, let's look at the types of problems that we have. I have both of these up here at the same time because they really overall do the same thing. If two people start at one point and go opposite, or they start at 2 points out here and go to meet, like the airplanes from Chicago to Atlanta, then their overall distance is going to be one thing. In this case, they said the overall distance is 1,000. How you find their overall distance is you add the two. So if this guy traveled 300 miles and their overall distance was 1,000, you would say, well, if this is 300, this is 700. Because this guy's distance plus that guy's distance should equal how far apart they are. Same thing if they're going towards each other. 300, if he traveled 300 miles and she traveled 700 miles and they met at some point, their overall distance is 1,000. So when you are traveling opposite direction or towards each other, you will add the two distances, okay? To come up with an overall distance. And these problems will either ask for the overall distance or tell you the overall distance. They will say they started 1,000 miles apart, okay? And that tells you right there that this is one that I'm going to add the two, all right? Let's look at the next one. Time head start. These are called catch-up problems. Someone catches up with someone else, okay? These are also same direction problems. So you'll notice that the first two were either going opposite direction or they were starting on some opposite and heading towards each other. These problems are going the same direction, all right? So if we're going the same direction, I could say Anthony left at this time and went there, and then Caleb left a couple hours later and went. And they were going the same direction and ended up at the same place. So they started at the same place. Even though someone left later, he still started at the same place. They ended up at the same place. These distances are no longer added together. These distances are equal because you start at the same place, you end at the same place. Your distance is equal. So once you set up these, you're going to set them equal to each other. Opposite direction, you're going to add them and they equal a total. These two will equal each other. All right? And look at the last type that we're going to do. Round trip. If I start at the front of the classroom and walk to the back of the classroom, and then start at the back and walk to the front and take the same path, it will be the same distance. So round trip are also equal. You'll notice that they did not add these distances up, that these distances also equal each other. And so when you start these problems, the first question that's going to come to mind is, what type of problem do I have? Do I have an opposite direction or towards each other? I know I'm going to end up adding some directions, adding some distances. Am I catching up with someone or am I doing a round trip? Those will equal each other. All right, so let's look at your handout. This says Judy and David each go on separate trips in opposite directions from Monterey. David drives twice as fast as Judy. David travels for 3 hours while Judy travels for 2. They drive a total of 324 miles. How fast and how far do Judy and David each drive? All right, so the first thing I'm going to figure out is what type of problem. Well, if I read this problem, they spell it out for me. Opposite direction. So I know that this is an opposite direction problem, and that's what I'm going to say. This is opposite direction here. So then the next question says, well, what do you know about this type of problem? Well, I know that the first distance plus the second distance will equal the total distance. So that is what my equation will look like. The first distance plus the second distance will equal the total distance apart. All right, so now we just have to set up a table for everything that they told us within this problem. So the first thing I'm going to do is I am going to look at these two people, Judy and David, and I'm going to start reading this problem and saying, what are they telling me? David drives twice as fast as Judy. Well, how fast does Judy drive? Do we know? Does it ever tell us how fast she drives? So we're going to give her a variable. We're going to say, well, she is driving R miles an hour. Well, David drives twice as fast. Algebraically, how would I write twice as fast as Judy? Yeah, 2 times R. 2R. R times 2 or 2 times R. And typically we would write it like this with the coefficient in front, right? 2R. Let's keep reading. So I've already accounted for their rate. Twice as fast as Judy. Let's look at their time. David travels for 3 hours. They straight up told me the time. His is 3.
So is it fine if we keep it in hours or minutes?
All right, how long did Judy travel? What's her time?
2 hours.
2. So we're going to put a 2 here. Now your rate times your time equals your distance, always. So to get this third column, I literally multiply across. All right? So I'm going to say R times 2. How do I write that, though?
2R.
2R. What is 2R times 3?
6R.
2R times 3 equals, this is going to be 6R. All right? I already decided what my equation is going to look like. My first distance. What is Judy's distance in this column?
2R.
2R plus my second distance. What is David's distance? 6R equals the total distance apart. That's in my word problem. What is my total distance apart?
8R.
Okay, but what is it in the problem? 324 miles, okay? So it says they drive a total, that's the total distance apart, of 324 miles. So yes, at this point, I am going to combine my like terms and I'm going to solve this, okay? So my like terms are 2R and 6R. My rules tell me to combine those. This becomes 8R. 324. What's my last step to figure out my R? Divide by 8. This is a decimal, that's fine. My R equals what? 40.5. 40.5. If I go back up here, what did I just solve for with the R? Judy's rate. Go back to your table and find that variable, R. R is Judy's rate. So how fast did Judy drive? That's what I just solved for. She drove 40.5 miles per hour. How fast did David drive? Well, on my chart, that's 2R. So I need to take 40.5 and multiply by 2. How fast did David drive? 81 miles per hour. Now it says how far. They want to know the distance, right? Well, Judy's distance is 2 times r. 2 times, what was my r? 40.5, right? Or I could say, just if I filled this in, right, her rate is 40.5, his rate is 81. Either way, 2 times 40.5. She traveled 81 miles, right? He traveled 6r, 6 times 40.5, or you could just say 3 times 81. Either way, you could multiply his rate and time, 3 times 81, or you could say it was 6r, 6 times 40.5. Either way, what is he going to drive? 243 miles. And I've answered all the questions at this point. A cargo plane flew to Hawaii and back. It took 20 minutes less time to get there than it did to get back. The average speed on the trip there was 300 miles an hour. The average speed on the way back was 280 miles an hour. How many hours did the trip there take? How long did it take to return? And how far was it? What type of problem is this? It's a round trip, there and back. So round trips, you'll always see the words there and back, or up the mountain, down the mountain, right? So you're going to see something that indicates they went someplace and they came back. So this is a round trip. And I know for these, my first distance is going to equal my second distance. I'm going to fill in what I know. Rate. Let's start with this column. What was the speed or the rate on the way there? 300 miles per hour. And what about the way back?
280.
All right, let's look at the time. It took 20 minutes less time to get there than to get back. Do I know how long it took to get back? No. So I'm going to put my variable for how long it took to get back. 20 minutes less time. How do I write that? So yes, I have to subtract the 20 minutes, but I have to subtract it in hours because that's how they gave this to me. Miles per hour. So if I have 20 minutes, it's out of how many total minutes? 60. So I can reduce that to what? 1/3. So for my time, I'm going to say however many hours minus 1/3 of an hour. Does everybody understand why I did that? I can't have minutes and hours in the same problem. This causes issues, okay? Has to be the same units. You could convert it all to minutes, but that would be really huge, okay? That'd be really big, okay? And typically miles per hour is what you're going to be doing it in. They were nice, though. This little fraction's going to go away, I promise. All right, to get my distance column, I just multiply across. So this first one is 300, and because I have a plus or minus in there, I have to put parentheses, t minus 1/3. I have to put parentheses there if there's a plus or minus in either one of those columns. On the way back, I can just say 280 times t. All right? So now my whole chart is filled out. I'm going to go back up and say, what did I say I'm going to do to set these up? Well, I said I'm going to set my two distances equal to each other, and that's how I'm going to solve this. So I'm going to say the first distance, which is 300 times t minus 1/3, equals the second distance, which is 280 times t. Okay? So far, so good? And what do I do to solve? Well, I need to distribute. Okay? So I'm going to distribute my 300 through. 300 times 3 is 300t. Positive 300 times negative 1/3. What's 1/3 of 300? 100. So minus 100 equals 280t. I have a variable over here, so I'm just going to subtract my 300t minus 300t. On the left-hand side, I have negative 100. What's 280 minus 300? Negative 20t. What's my final step here? Divide both sides by negative 20, whatever's with my variable. So 100 divided by 20, t equals how many hours? All right, 5 hours. What did I solve for? The time for which one? The way back. So which of these am I going to fill in? The return flight. The return flight was 5 hours. That's what my variable stood for. On the way there, it took 20 minutes less. What is that? 5 hours minus 20 minutes is 4 hours and 40 minutes. All right? 4 hours and 40 minutes. What was the distance to Hawaii? Well, I can just plug in my 5 hours right here. 280 times 5, right? That's the easiest one to plug it in, I'm sure. Don't do minutes. 280 times 5 should equal the distance because there and back is the same distance. So what happens when I do 280 times 5? I get what? 1,400. So 1,400 miles is how far away it was. That is there and back. All right, this is on the second page. Sorry, they're out of order. Trey and Justin left for a trip down the river in a canoe maintaining a constant speed of 3.7 miles per hour. 3 hours later, Trey's father set out after them in a motorboat carrying camping supplies. The motorboat travels at 16 miles an hour. How long after he started did Trey's father catch up with the boys? How far had Trey and Justin traveled, and how long had they been on the river? All right, this is a catch-up problem, or same distance, or head start, whatever you want to call it. I call them same direction. All right, same direction or catch up. Someone leaves, someone catches up with them. If they leave at the same point, even if they don't leave at the same time, and they catch up with them, then they are at the same point when they catch up. Their distances are the same. So for this one, your two distances are the same. Let's see what we know. We're going to fill in what we know. Trey and Justin, do we know their rate? Yes, 3.7 miles per hour, yes. Do we know Trey's father's rate? Yes, 16 miles per hour. All right. Here's what we don't know. Do we know how long they traveled? No, we do not. So we're going to say they traveled T hours. Trey's father left 3 hours later. Who traveled longer? The boys or Trey's father? The boys did. He left later, right? Okay. And so if you took their time and subtracted 3 hours, you would get his time. He left later. All right. If they traveled 5 hours, he waited 3 hours before he started driving, right? Or driving the boat. So he only traveled 2. So whoever leaves later is traveling less time. So we're going to take their time and we are going to subtract 3 hours. Here's something else you can tell. Whoever's going faster is going to travel less time as well. Does that make sense? I mean, their distances are the same. So clearly going 16 miles an hour, you shouldn't travel as long than if you're going 3.7 miles an hour. Okay? Does that make sense? And so wherever it's faster, there's where you're going to subtract the time from. Whoever's going faster is going to have the less time, which makes perfect sense if they go the same distance. Okay? So he left 3 hours later. I'm going to take however much time they traveled and subtract 3 hours from it. Okay? My third column is always going to be the same. I just multiply across. So their distance is going to be 3.7 times t. His distance is going to be 16 times the group, t minus 3. Anytime you have a plus or minus, put a group around it. I already said these two equal each other. I've already said that's the case. So I am going to set those equal to each other. 3.7t equals 16 times t minus 3. And then I'm going to just solve. 3.7t equals this distribution. 16 times t, that's 16t. 16 times negative 3 is negative 48. All right. Subtract your 16t from both sides. All right. 16 minus 3.7 should be negative 12.3. That was a negative 16 and a positive 3.7. All right. Then divide both sides by the 12.3. 48 divided by 12.3. You get 3.9. 3.9. That is which person traveled that long? The boys or the dad? The boys. Go back to your chart. What is T? T is how long they traveled. If you do the same, this is 3.9 hours or 3 hours and 54 minutes. If you multiply 0.9 times 60. How far did they travel? That is their distance. How far they traveled is going to be 3.7 times 3.9. That's how far they traveled, right? We said their distance is rate times time. Their rate was 3.7. Their time was 3.9. They traveled about 14.4 miles. How long did their father travel? Well, they traveled 3 hours and 54 minutes. He traveled 3 hours less, 54 minutes, right? 54 minutes for him.